Hey, today I wanted to go over corroborating answers from multiple web sources. This is not a Google paper, but Google does use this. So let's just jump into it right away. Unfortunately, many web sources are not trustworthy because of erroneous, misleading, biased, or outdated information. So that's the problem that it's trying to solve. In this paper, we propose methods to aggregate query results from different sources in order to save users the hassle of individually checking query-related websites to corroborate answers. In addition to listing the possible query answers from different websites, we rank the answers based on the number, importance, and similarity of web sources reporting each answer, as well as the importance of the answer within the sources. The existence of several sources providing the same information is then viewed as corroborating evidence, increasing the quality of the corresponding information as measured by a scoring function used to order answers. Our techniques are built on top of standard web search engine. We address the following challenges. They aggregate answers from several web sources. Our proposed approach takes into account the frequency of answers in the web search engine result, but also importance and originality of the pages reporting the answers, selecting the web sources from which to retrieve the answers. Corroborating answers. A first step towards aggregating query answers from multiple web sources is to identify potential answers from the list of web pages returned by a search engine query. Once those answers are identified, similar answers are combined and scored based on their importance in their search engine results. This table over here, the queries containing the keywords. So here's the length, distance, mileage, width, temperature. So that's their example keywords. The average number of clicks for all queries, including the queries with 0 clicks. Average number of clicks for queries with 1 click or more. In this table over here, I'm going to scroll down. Average number of clicks per query. In addition, as a first step, we only focus on queries whose answers are numerical values. That's very important in this paper, that they really focus on numerical values. It is easier to identify numerical answers within web pages. For instance, mileage information will typically be of the form X MPG or MPG of X, where X is a numerical value. So think of a car, and we'll get to an example in a bit. Our preliminary analysis of about 15 million MSN query logs shows that keyword queries for which numerical query answers are expected, e.g. queries containing mileage length, tend to result in more search engine user clicks than other queries. This result suggests that users are not satisfied with the answer to numerical queries found in a single web page and tend to check several sources to corroborate answers. We consider that a page ranked highly by the search engine provides better information than a page with a lower rank. Therefore, an answer found within the higher ranked page will be scored higher than one found within the lower ranked page. And it's not too different right now with LLMs. The duplication D between pages, our scoring aggregation technique takes source similarity into account to reduce the effect of similar information coming from the source in the same domain, or sources that seem to be mirror or copy-paste information from each other. Ranking answers. Finding and scoring answers is not the only challenge we face when corroborating answers from the search engine query results. Another challenge is to select the set of result pages from which we extract information. Specifically, we have to decide how deep we should go in the search engine query result. Work on top K query processing algorithms has focused on adaptively reducing the amount of processing done by query evaluation techniques by ignoring data that would not be useful to identify the best answers to a query. So some practical tips from the paper. Put the direct answer on the page. The paper says numerical answers are easier to identify because they often follow patterns like X MPG or MPG of X. It also found that numerical queries such as mileage, length, distance, width, and temperature tended to get more clicks than general queries, suggesting users often check multiple pages to confirm the answer. So the SEO takeaways: add clean factual answers, especially numbers, ranges, prices, dimensions, dates, ratings, and specifications. Another tip: put the answer close to the query subject. The system prefers the value closer to the query subject. In this example, 51 MPG is closer to Honda Civic, while 33 MPG belongs to Toyota Camry. An example: bad Toyota RAV4 fuel economy depends on the model, trim, drivetrain, and year. A better example is the Toyota RAV4 gets about 25 to 41 MPG, depending on the year, trim, and whether it's gas, hybrid, or plug-in hybrid. So these are attributes of the entity Toyota RAV. Let's go to the search results. Toyota RAV4 miles per gallon. Toyota RAV4 fuel economy depends on your powertrain, ranging from an EPA estimated 30 miles per gallon combined. And in the people also ask, you can see how many miles per gallon does a Toyota RAV4 do. A Toyota RAV4 gets between 25 and 47 MPG, so it has a range between those numerical values.